Hello and welcome to the course Introduction to the Psychology of Language. I am Dr. Ark Verma from IIT Kanpur, and we are now starting the 6th week of the course. In this week we will be talking a little bit about reading, and we will be covering various aspects related to the skill of reading, whatever the mental processes are, what are the mental processes involved in reading. Also we will talk a little bit about difficulties in reading, or say for example components of reading like script, and how do you move your eyes to get maximum information, all of those kind of things. The topics that I mentioned will be spread over the next 5 lectures. In today's lecture I will start basically with asking some very basic questions about reading, and I will also start talking a little bit about one of the most important issues about reading, that is movement of your eyes. So without wasting our time, let us try and see what reading is about. And there is this definition, or there is this comment on reading by Goff and Hillinger that Traxler mentions, and I am kind of putting this up here for you to read and reflect. And this is how it goes. It says, reading is an unnatural act that involves close coordination of motor, visual and cognitive functions. So let us try and discuss a little bit about this particular definition and what does it really say. It's not really a definition, it's more like a comment on what a reading should be. Now the first thing that you would notice is that they're calling reading an unnatural act. Now you might wonder why so, and a simple answer to that would be that we are not designed to read. Okay, as organisms, or at least maybe now, but in the initial period we were not really designed to read, in a sense that we create symbols and then we decipher those symbols to get information back from them. So that kind of process is not really something that we were prepared for biologically, evolutionarily, or in any which way, or in a societal way, or so to speak. So in that sense, if you see, reading is something that is sort of completely a man-made skill. It is something that we developed the scripts, and then we developed our abilities to interact with the script to gain information out of it. So that is something that is very important, and in some sense is something that fascinates us about this capability of reading, is because if you remember in the last chapter I was talking about the visual word form area and the phonological word form area. So apparently it seems that something that we started thousands of years ago, so to speak, now the brain is kind of involved in that skill to such an extent that there are dedicated areas of the brain that might be handling this kind of thing. So there is a visual word form area that helps you decipher whatever script is written at some place, and you get some information out of it. So in that sense it may be therefore said that reading is an unnatural act, in a sense that we are not naturally wired to read. It is something that we have developed as a species a few thousands of years ago, and we are kind of continuing on that. Say for example, generations after where reading started and our generations that have to come later, we kind of have introduced them to script in some sense of the word, and that ability to read now is considered as an integral part of whatever cognitive mental functions that we have. So that is one part. And then the other part that is important in this comment is that reading involves the close coordination of both or 3 kinds of functions: motor functions, visual functions and cognitive functions. So cognitive is still kind of an umbrella term, I will come to that, but what is motor and what is visual about this? Basically they are one and the same thing, in a sense that you have to move your eyes in a coordinated systematic fashion in order to gain maximum information out from the script. So for example, if you are reading this, you are reading this word by word, or say for example you are reading just one word and then skip few and then read the 3rd word and the 7th word or so on, you are basically still, if somebody were to record your eye movements for a fixed period of time while you are reading a text, maybe 1 page, 2 page, whatever, what can be discovered very easily is that there is a pattern to how your eyes move. There is a pattern to how you move your eyes over the text and gain information from the script. So that is something which is very, very important. Also visual functions, say for example, scripts are not really just random shapes. They have with them a lot of information compressed into this, into their symbols. Say for example, we were talking about words, and we were wondering that how much information that a word has. All of that needs to be deciphered. It's, say for example, there are so many different scripts, and there are so many different say for example, symbols in the script. English in that sense is slightly simple, that it has 26 alphabets and so on. But say for example, take a script like Hindi, which has so many alphabets, and they have, in addition to it, it has so many diacritics, and it has half alphabets, and it has basically those small signs that come on the top and the bottom, and all so many different kinds of signs, and they are used in quite a few different permutations. So in that sense, or say for example, Chinese or Japanese, which are even more complicated scripts in some sense. And the idea is that, say for example, for those kind of scripts, there is a whole lot of information in just one symbol. In Hindi and English for that matter, the letters or the alphabets, or say for example the aksharas, if you are talking about Hindi, kind of have some information, but they still have to be in some sense combined with other syllables or other aksharas or other alphabets to create a major percept, to create a major word and so on. But there are scripts that we know of that basically one symbol is already a word, or sometimes an entire sentence in itself. So in that sense, the visual analysis part is also very, very important, and the thing is, you have to coordinate the motor and the visual parts of it, because you have to move your eyes in such a way that you can maximize the information uptake from the script. So that is basically only going to be possible if the motor part, or if the movement part of the eyes is happening in consonance with how you are visually analyzing a given script. So you have you have to be coordinating these two processes, and sometimes, because we've kind of learned to read, we are from the literate sections of the society, we don't really think that this is so very complicated, but the fact is that this is something that we take some time to learn. Children take some time to learn, and children take some time to coordinate these two things. So in that sense, it's a very sophisticated function that is known by the name of reading. And then there is this third aspect that the comment talks about, is cognitive functions. What are the cognitive functions that I might be talking about? I mean, to basically just name a few. We can talk about, say for example, we can talk about meaning making. We can talk about, say for example, going from the graphemes, that is the script, to the sound, that is grapheme to phoneme conversion, and from the phoneme conversion to you go to the actual word, you create meaning, and the meaning kind of leads you to so many different areas. You have to overall understand the symbol and the word that you are reading, and you have to also integrate that symbol or the word into the larger sentential context, or in the context of what eventually you are reading, what does it mean, how is it written, all of those kind of things. What are the processes that help you to go from grapheme to phoneme to meaning. So all of that basically is again is a set of mental functions or mental processes that you will need to coordinate in a very you will need to perform them in a very systematic manner, in a very coordinated sense, in order to be able to successfully read at least one script, so to speak. But we know that people are kind of bilinguals, and bilinguals in terms of reading as well. So there are people, say for example, who would be able to read Hindi and English, and sometimes Hindi words written in English script, or English words written in Hindi script. So these are some of the very basic questions that we would probably need to ask ourselves, and we will touch upon some of those questions in this week in the different lectures that are going to be given. So again, just to leave you with this, I'll just repeat this again, and you could kind of reflect on what we've talked about right away. So reading is an unnatural act that involves the close coordination of motor, visual and cognitive functions. So motor is movement of the eyes, visual is how much information and how you're getting information from the symbols, and cognitive functions basically refer to meaning making, integration with the context, and all of the other set of functions that we have actually talked about in the past as well. So with this preface, with this kind of background to what reading might be about, let us also talk about, say for example, what are the cognitive processes in reading. What is it that the brain does, what is it that we do in order to be able to read properly. So that part is something that we would really need to take care of. And let us ask ourselves this question. Say for example, one of the first things I can think of doing as a part of reading is this aspect of converting the written symbol to the sound symbol. Say for example, any number of symbols can be written, and you have to analyze them visually. You have to see, okay, is this a horizontal line, or is this a slanted line, is a vertical line, and in what sequence they are arranged, so that you kind of go from that grapheme. So that aspect is called grapheme. That visual symbol that is linguistically meaningful is referred to as grapheme, and you have to analyze that grapheme for information, convert it into a phoneme, and as you see, say for example in Hindi or English, for example, it's written from the left to right. In a sort of a linear sense, you have to concatenate and join these graphemes and the resultant phonemes in order to construct words. So that is also a very, very important process that we do, and then we kind of go to the sound. You have to access the sound, and then once you have the sound representation, what you go for is called lexical access. We have talked about lexical access in some detail, and we have kind of, if you remember, reason that it is not really a very, very simple process, not a one step process. There is feature level, letter level, and word level in the trace model that we talked about earlier. And then from that, it's meaning making, it's it's integrating the meaning with the entire sentence and then the entire paragraph, and in a broader scheme of things, what did I read when I read this particular chapter. So there are these mental processes that you will need to do successfully and in the right manner in order to be able to read successfully even one page of text that comes your way. So that is something that we will talk about, and let us just kind of detail that a little bit again. So to read efficiently, what do we need to do? To read efficiently, we first need to activate the stored phonological and semantic representations right away. At the same time, at the right time, when you are reading, say for example, you started with a particular location on the page, and you are moving from left to right, and then coming to the next line, and then again moving from left to right. All of those activations from the grapheme to phoneme to the meaning have to happen simultaneously, very quickly, and in a way that your speed of reading. So you do not take loads of time to read one sentence or one word or one letter. You do it in a fairly rapid way, and that is also very fascinating, that you have to do this entire page of text, moving from one set of symbols here to from the left to the right, and you kind of do that at the same time. Also at the same time, you have to engage in these higher level integrative and inferential processes. Say for example, what did the sentence mean with respect to whatever I have heard till now. A lot of times what happens is that, suppose you are reading a thriller novel, or you are reading some very complicated poetry. You kind of come back, you come on the 4th line, 5th line, maybe the next paragraph, and and then that string of thought loosens up. So you go back, you read it again, and then you come back. A lot of time people kind of do this back and forth, and trying to maintain that string of thought, that they are understanding what they are reading, and also in a sense that they are kind of making sense of whatever this text means by itself, and also in the larger scheme of things. Say for example, there might be a small incident, but in the say for example in thriller, if you are reading, there might be small instances, but they are connected something to something that is much happened much earlier. So in some sense, reading also kind of invokes you to keep those memory traces active, and to kind of help you be able to keep these integration and inferential processing alive and all right while you are reading texts. Also something that is very, very important is that how you move your eyes across the text, how you move your eyes across the page, at what speed, at what distances. Is it like from one point to another point, or is it in a gradual way? How is it that the eyes really move in order to facilitate your visual uptake of the information from the graphemes? So that is also very, very important. So these are these three very basic processes, slightly broadly put here, but you have to do that in order to successfully read any amount of text that you need to negotiate. Now, if as a psycholinguist, if as a as a scientist, you have to kind of try and understand the sets of processes that go into reading, people have, and Traxler also kind of divides it into two kinds of processes. One where basically involve the movement of eyes and the control of eyes while you're reading, and the second is basically about the higher cognitive processing, the meaning making and the integration and all of the grammatical judgments and all of those kind of things. And there are many related questions that you could ask. Say for example, as I was giving you an example of Hindi and English, I could give you an example of Hindi, English, Chinese, and so many other languages, that the scripts are also in some sense very different from each other. Even in India, say for example, there are so many of these Indian languages which basically as far as speaking is concerned might sound similar, but the scripts might be very, very different from each other, and you have to kind of if you have to negotiate reading in 2-3 scripts, you have to kind of know which symbol belongs to what script and what does it sound like and what does it mean like. I can kind of remember say for example in the Arabic or Persian scripts, sometimes the diacritics or the matras that we talk about in Hindi are not specified at all. So Hebrew for that matter is a very good example. In Hebrew the matras are not specified. So basically what you actually read is mostly consonant consonants that are written one after the other, and you have to remember the matra. So an early Hebrew reader kind of still finds them specified in the script, but for the most part when adults read the vowels and the matras are not really specified, and you have to kind of remember them, or it should be in your expertise that you kind of can decipher the matras correctly, because that is how you will be able to read the entire text. Related questions could be, how do people or how do children learn to read each specific script? Say for example, how do children read the alphabetic scripts in English for that matter? And a related question also is, say for example, as I said that reading is an unnatural act, we are not really wired for reading. Reading is not really also an innate skill that comes with that comes with birth. We need to acquire reading, people need to instruct us how to read and into what scripts to read and so on. And that kind of brings us to this knowledge of that not everybody, not all the children that start to read or begin instruction in reading can read eventually at the same level. So there is that thing as well, that not everybody masters the skill of reading equally well. There are some people who are very, very good readers, and there are some people who are sort of average readers, and there are some people who are poor readers. There are people who suffer with deficiencies in their reading abilities, and say for example there are specific cases which are which can be classified into particular disorders like dyslexia, but then there are other people also who are not very, very good at reading, but they might not really be dyslexic to begin with. So there are some of these questions which we need to ask ourselves, and we'll probably talk about them in some detail in this chapter. So we can kind of now move into the first topic in the chapter, which is eye movements in reading. So let's talk a little bit about what kind of eye movements are required. Suppose you're kind of taking a page, newspaper, or on a paper that you have in your hand, and you're kind of just randomly moving your eyes all throughout the page. Will that amount to reading? I mean, you might still your eyes might still fall on a location where a word is, and you might pick up that word, but if you kind of randomly moving your eyes across the page, you're not really reading. That basically tells us that yes, eye movements, especially when you're reading and not really just scanning a particular scene, tend to be very, very systematically organized. And this systematic organization basically is in such a way that you start always on one particular location on the page, Usually, say for example, in scripts like Hindi and English, from the left side, and from the left side you kind of move gradually in a very systematic fashion from left to right on one line, and then come down and then again start at the leftmost and then move from left to right, and then change line, again start from the leftmost and move to the rightwards. Okay. So, this is basically how you extract information from the script, and you get to read whatever is written on that text. When you talk about eye movement, so let us kind of spend a few minutes on talking about different kinds of eye movements that are there. And in eye movements, there are multiple kinds of eye movements that people have identified, some of which might be relevant to reading, some of which might be relevant to barely looking out into the world, scanning the scene and so on. So, one of the first kind of eye movements that one could talk about is smooth pursuit. Smooth pursuit the easiest way to understand how smooth pursuit eye movements really are is like, suppose if there is an object that is moving in the visual field and I am kind of tracking this object with my eyes. A lot of times people are kind of standing somewhere and there are vehicles going by. If you try and track those vehicles from the left part of your visual field to the right part of the visual field and outside into the periphery, this smooth movement that really happens, a continuous smooth change in this direction of gaze is where you are looking at, is called smooth pursuit. It is mostly used in tracking moving objects. Okay. So, that is smooth pursuit. Other kind of eye movements that one could talk about are the saccadic eye movements. Saccadic eye movements basically occur when you are trying to read text, and you basically then you scan in the direction of the text. Suppose if you are reading Hindi or English, it is usually from left to right. If you are reading Urdu or Arabic, then it will be from right to left. So, basically the eye movement is kind of now tied to what script you are negotiating, what script you are reading, and kind of will follow the pattern of the script in order to maximize or optimize your information uptake from the script. Okay. So, saccadic eye movements, or say for example have quite a few things. There are times within this where there are relatively long periods of time where the eyes are stationary in their orbits. They are not really moving a lot, they are just around there. And these are basically connected by very short bursts of rapid movement. So, there is this place where your eyes are stationary for a bit, and then they move to the next point, and then move to the next point, and then move to the next. These movements, these short bursts of movements are referred to as saccades. Okay. So, saccades are rapid eye movements from point A to point B in the visual field, and they are sort of very fast. They usually take around 20 milliseconds to reach from one point to actually it takes around 200 milliseconds. There might be a typo here, 200 milliseconds from start to finish. And the purpose of these saccades, basically, why do you need to move your eyes? You can keep your eyes stationary and get the maximum information out of it. So, that could be a question that somebody could ask, and the answer to that question is that what saccades are trying to achieve is they are trying to achieve maximum visual acuity. So, I will talk about this very shortly, but when you are looking out into the visual field, when you are looking out into the world, or looking out onto a page of text, the information that you can uptake from there is not uniform across the entire region. Suppose if this is a page, you will not be able to get information uniformly from this section, this section, this section, or from the top or from the bottom at once. Usually what happens is that the information is is best is in its highest resolution, if I might borrow that metaphor, is in its highest resolution at the place where the information can be directly projected onto the fovea. So, fovea is a short is a small portion of the eye at the back of the eye at the retina. I will show you some of those figures very quickly. So, basically what we are trying to do is or the eyes are trying to do is to get the information at the fovea, so that you can get maximum information and then move to the next location, get that information onto the fovea, take information in there. So, the entire purpose of these eye movements, or these saccadic eye movements, is basically to sequentially bring each part of the text, one word, second word, third word, fourth word, onto the fovea, so that you can at best and in the best way possible take up this information and analyze it and make it available for conversion of grapheme to phoneme. Okay. Now, in that sense you might ask, okay, why is this kind of visual acuity important? Why do we need that high degree of resolution, that we have to kind of move our eyes in a sort of a tiring manner, so to speak, and to get all of this information on the fovea? Now, basically visual acuity is important in a sense. If you kind of think a little bit, and if you look at the kind of scripts that we navigate with, or that we negotiate with, sorry, the scripts have very peculiar minor differences. Say for example, you might all be aware of the difference between the only differences that it's almost sort of a reversal thing, and the P and Q and N and M, and there are so many of these alphabets which can be confused with each other, and if they are written as a text in a shorter font altogether, then obviously you need to be very careful. You need the highest visual acuity to get that information correctly, because that is the building block of whatever you are going to read. So, in that sense, that is very important. In scripts like Hindi, for that matter, it becomes even more important, because scripts like Hindi have almost a non-linear arrangement of aksharas and matras all around them. So, you have aksharas, you have half aksharas, and you have matras on top, on the bottom, on the left, on the right, sometimes marked onto the akshara itself. So, there are so many of these matras, and in that sense you would not want to mistake one akshara for another, or you would not want to miss say for example, it is a very simple thing, say you can so there is this word called ank in Hindi, and the only thing is and ka, the aksharas are there, and there is a small bindu, a small dot on the top of it. So, the thing is, you have to, in that sense, be very careful of even that dot, because otherwise the word will not make any sense. So, in that sense you need the highest acuity information possible, or highest resolution possible, highest visual acuity that is possible to get, and that is only possible if the information is falling directly onto the fovea when you are looking at it, and that is basically what the eye movements are trying to do all the time. Now, one of the things that also, so we talked about smooth pursuit, we also talked about saccadic eye movements. One of the things is basically when these saccades are happening, when there are these rapid saccadic eye movements taking place, there is another phenomena that kind of intervenes this, which is called saccadic suppression. And saccadic suppression is basically when you are moving from point A to point B on the visual field, all the information in the middle is it basically looks like a big blur. Okay, it is not really something that you also have information for. Say for example, if you are reading first word of a sentence and then the third word, and you immediately move from the first to the third, or you skipped the second so to speak, you will have less information of the second word. Mostly the second word could be just a preposition, a grammatical thing, a determiner, or a and the kind of thing, and it does not really matter if you skipped it, because you are still making decent sense out of the entire thing. But suppose you kind of miss an important word, then you kind of are messing up with the entire reading thing, it is not going all right. So, in the middle, when you move from point A to point B, that part is called saccadic suppression. No information can be actually extracted during the saccade is in motion. Why is this happening? Why do you not get more information while you are moving the saccade? Partly because the visual image that falls on the retina during the saccade is mostly a blur. It's not detailed, and it's so fast that you don't really register a lot from there. Also, there is very little time for activity at the retina to send activation to the visual cortex. So, you also have to understand how reading is happening, and part of it is when you are foveating at some place, the retina is receiving some impressions from the script, and those impressions need to be sent to the visual cortex at the back of the brain, the occipital cortex, which kind of makes meaning out of the symbol. So, it says, okay, this is the symbol, this symbol actually means this. That part takes a little bit of a time, and while you are in the saccade, while you are moving from point A to point B, jumping from here to there, this time period is also very small, and you really cannot kind of process information so fast that you will be able to take information while moving the eyes itself. So, that part is there. So, that is why saccadic suppression happens, and research basically shows that in order to really get some information from the script, you basically need at least 50 milliseconds of exposure. During the saccade moving from point A to point B, there is not that kind of time available, and that is why you will not be able to actually process any information between that. And this loss of information, basically there is also a technical term for that, which is called eye brain lag. Okay, the eye brain lag is basically the amount of time it takes for the neural signals from the retina to affect the neural signals in the primary visual cortex area. So that time, say for example how much time it took. So this 50 milliseconds time is the eye brain lag, which the eye takes to move information from the retina to the primary visual cortex in order to for you to convert the grapheme to phoneme and make more sense out of it. Now we can come to other kinds of saccadic eye movements. When the eye movements are in the direction of the script, left to right, they are referred to as progressive saccades. If the saccades tend to move back, suppose you are reading this particular sentence written here, you go from this word to this word to this word and suddenly come back. This coming back is called a regressive saccade, moving from one point. You read this one, got information, then you move to this one, got information, you move to this one. So these were progressive saccades. While when you have to come back, sometimes you read the sentence, at the end you do not really understand something and you come back. This coming back is called a regressive saccade or a regression in eye tracking papers. Regression basically usually happens when, say for example, something has gone wrong with the process involved in interpreting whatever the symbols are, whatever the words are, or comprehending the text, and these regressions are basically then where do you come back to. So these are targeted towards parts of the text that may be helpful in resolving comprehension problems. Suppose there is a sentence, Ram came Ram came home while he was very hungry, and then he put jam on his socks and ate it. So something like that. So when you he put jam on his socks, you will kind of try and go back to it and say, make sense of what is it actually, whether I have misread something or the sentences. So some kind of scenario, or say for example very simple actual sentences, sometimes you do not understand it and you want to come back and check what has really happened. So the readers basically also, in that sense, you know how can they come back to the exact same area where there is some problem, so the regressions are targeted toward parts of the text where that may be helpful in resolving any kind of comprehensional problems or ambiguities. Now how can readers exactly come back to that same point is because readers do maintain a sort of a spatial map to keep track of syntactic choices, to keep track of semantic ambiguities and so on. Okay. So we've done this chapter on sentence processing. You see that so many different syntactic choices need to be made, and if you're doing it sort of unconsciously, semi-consciously, you'll need to come back. Achha, was this a verb? Was this a noun? How was this there? Where do I attach this sentence structure? You'll need to come back. You'll need to do a lot of this forward saccade and regressions in order to kind of do this in an error-free sort of a manner. In this duration, your eyes are resting at some point of time. Suppose say for example you move from point A to point B, you spend some time here before you move there. The time that you spend here, the time that say for example you're fixating directly at is basically called fixations. Okay. So these durations basically are sort of close to around 200 to 250 milliseconds, and sometimes the eye can directly land towards this. Say for example you started with reading at particular location on the page, so you kind of started with there and you spend around 200 to 250 milliseconds there and then moved to a different place, and then if you stayed there. So all of these basically are called fixations, and fixations basically allow you to uptake a lot of information from the text that you are fixating or the text that you are gazing directly at, looking at eventually. So that is also something important. Now another thing that I could talk to you about is the perceptual span. So when your eyes are fixating at a particular place, how much information can you get? Say for example if I am looking at this second word of the sentence, can I kind of get the whole sentence in my view, or I am just getting information from that say a word that I am fixating from. So that can be answered in a sense by this concept of perceptual span, and the perceptual span is basically the region or the area of useful vision, you know, the area that you are gaining information from while you are resting your eyes at that particular place. And that kind of can differ from from the skilled reader or to the novice reader, but usually is around from say for example 4 characters to the left till around 15 characters to the right, and this will be basically for Hindi or English. So if you are fixating at a point here, 4 letters to the left and 15 letters to the right is what your perceptual span would be, and the acuity will also not be the same in the entire 19 letters or 20 letters. Basically the acuity will be highest at the center where you are actually fixating, because that will fall on the fovea and will tend to reduce as you move on either side of the fixation point. Let us look at some of the figures that will help us understand some of the things I was talking about. So you can see a forward circle. So the sentence is Sally was admiring the wet grass and noticed the dew created tiny little drops of water around her feet. So you can see say for example the person started reading from Sally and then moved to was, and then moved to admiring, and then skipped the moved to wet, and so you can see that this is basically what the thing is. And if in the second line you can see from drops of water, there is a from drops to little, there is a regression that has happened. So somebody is kind of looked back. Okay, what did I read now? I probably missed it or didn't understand it clearly. So you can see forward saccades, you can see skips, and you can see regressions here, and you will see a little bit of a refixation sort of here, wherein say for example if you fixated at this point, and then because the word was longer, the word around has almost 6 letters to it, so you kind of refixate at the same letter, and you will also see the return sweep from the end of the sentence to the beginning of this sentence. So these are some of the eye movements that you can see. Here in this figure you can see the fovea in pink on the right. Fovea is a little kind of bulging area there which has the highest density of rods and cones, and kind of that is why it provides you the maximum resolution. If you really need to know a little bit more about this, I think I have recorded this in the course Basic Cognitive Processes, and therein you can kind of go and read a little bit about where I have talked about perception. Now this is basically how the range, the spatial area is organized. You can see from 1 to 2 degrees is the fovea, and then from 2 to 5 degrees is the parafovea region around the foveal region, and then 5 degrees and onwards there is something that is called peripheral vision, and you will see the visual acuity is very different. So from 1 to 2 degrees there is the highest visual acuity, from 2 to 5 degrees it is a little less, and from 5 degrees onward it is very less. So you might need to move your eyes again within the within that spatial area to get information. This is exactly how it looks. So the fixation part, you see there is 100% acuity at the number 4, and then if you move towards the left and towards the right, you see the acuity is kind of dropping off. Okay. So around the fixation only about 4 to 5 letters are seen with the highest visual acuity. So if even if a single word is long, you might not really be getting in full information from the end of the beginning of the word. So this is basically something very important that you need to keep in mind. Now we talked a little bit about different kinds of eye movements that are involved in reading. We can also talk a little bit about, say for example, what are the experimental paradigms that have been used to investigate the role of eye movements in reading. So there are these 2 particular paradigms that I would like to mention, which are very popular in reading research, so to speak, which kind of uses eye tracking methodology. One is the moving window paradigm. Now moving window paradigm is basically wherein a part of the text is replaced by something else, say for example XXX, to manipulate the part of the text that the readers are actually looking at any point in time. So basically you want to be sure that the reader is picking up information from only the part of the text that you want him to read and nothing else. Say for example, if you want to really see how a person is processing a particular word, and there are so many words here and there are so many words here, you cannot really be sure of what the person is reading. So what you do is you kind of keep this word intact, but convert all of this into x and all of this into x. As soon as the reader has read it around 200 to 50 milliseconds and the reader needs to move to the next, this one becomes exposed and this becomes xs and this becomes xs, and then another, this one becomes exposed and this becomes xs and this becomes xs. Let me give you an example. So this is a sentence. So if you kind of saw this, give me 3 steps. Okay, so everything else is basically just x's, and on each of these slides I exactly know that you are processing that word, and whatever your fixations and patterns, saccades, microsaccades, etc. are there, I can be sure that those are in response to that particular word, and depending on whether that word is a high frequency or a low frequency word or a complicated word to read or an easy word to read, I will know if that pattern kind of corresponds to your eye movements pattern. So that is the basically the important point here. And this can be done easily using feedback from an eye tracker. An eye tracker is basically a device that kind of is a very simple device. It basically is a sort of a camera, and there is an infrared light source, and the light source kind of projects a ray of light to your eyes and it reflects back on whatever you are reading, and then there is this camera is tracking that light source, and basically in that sense it is mapping how your eyes are moving on the visual field or on the line of text that you are reading. Okay. And then so because in this paradigm you are only reading one word at a time, what happens is when only one word is visible at a time, the word boundaries and are coinciding with x's, the reading speeds become almost 20% slower than how somebody would naturally read, and that is intuitive and that can be expected. Now when the preview of the next word and word spacing information are both eliminated by these extra lines and x's, reading times almost double. So you kind of become slower by almost 50 to 60%. So this is basically again a demonstration of the moving window paradigm. The other paradigm that you can also talk about is the boundary change experiment, wherein say for example you do not really keep everything as x's, but you kind of have invisible boundaries. As soon as when the reader's gaze is to the left of this boundary, the critical text is either displayed as normal or is distorted in some way, and as soon as you change the boundary, the nonsense letters are replaced by normal letters. Say for example, give me, and then there is a boundary and here there is random letters. As soon as these boundaries cross, this becomes 3, this becomes random letters, this becomes random letters. So this is the boundary change experiment, and basically the idea behind this boundary change paradigm is to deny the readers any kind of preview of the next information. When we move further, we will talk a little bit about how preview might be helpful. Preview is basically that because when you are reading this particular word and you are fixating on this particular word, are the words here or the words here also sort of giving you some information? Are you kind of getting any preview information before fixating those words? So that basically is called preview, and usually is referred to by the term of parafoveal preview. So fovea is what you are actually getting information out of, and then there is this degrees 2 to 5, that area wherein also some information can be easily gotten to read, and that information also interacts with your speed of reading and so on. So that parafoveal preview is denied in the boundary change paradigm. Now there is some research that suggests that readers can also sometimes identify the final letter in the word to the right, that is not what you are foveating, if the word is 5 or fewer characters long. So for example, the length is smaller, and if that area is falling in the parafovea, you can actually tell us what the last letter of the next word is, which you are not really fixating. Okay. So although obviously the image of this letter is much blurrier, it is not in your it's not in your foveal vision, it does not really suffer from visual interference from the adjacent letters, and this is basically called lateral masking. So you kind of still getting some information out of it. Now being able to identify letters from the word to the right of fixation helps sometimes readers to better predict, and and also say for example, because you have processed that a little bit earlier, when you reach that you can be fast about it. Say for example, the word that you have had no preview of, you will spend some time 100, 200 milliseconds whatever in getting information, and while you are getting information from there, suppose there is a mechanism that is also getting you information from the next letter, when you reach this one you can be faster about it. Or say for example, if you realize that okay, this is just a preposition on an article, a and the kind of thing, you can decide to skip it and move to the next one, and you are still getting another parafoveal information. So parafoveal information in that sense is something very, very crucial in order to ensure the speed of your reading, also in order to ensure the correctness and the accuracy of your reading. So however, I mean, so visually it can be a lot of help, even though the information's resolution is not very high. The acuity, obviously, as we discussed, is slightly lower. Also, however, finally we can say that no semantic activation really happens. So you are not probably getting a lot of meaning out of what is there, but you still can get the visual information out of it. So in that sense, that is something which is slightly important, and one would need to know that. So also another things is say that the size of this reading window that we talked about, 4 letters to the left and 15 letters to the right, is also something that matters. So the size of the reading window kind of matters in order to determining your speed of reading that entire text. Now, so that's basically what we said. 4 letters to the left and 15 letters to the right is basically your reading window time. If you notice that 4 to the left and 15, this is not really a symmetrical window. Basically, this is an artifact of reading direction. So if you are reading from left to right, this is 4 to the left, 15 to the right. If you are reading from right to left, as in Hebrew, it will be 4 to the right and 15 to the left. Okay, this is again something that you develop in response to the script that you are learning to read. Okay, so again something that you are picking up. You are picking up the skill, and the system is organizing itself according to the script that you are learning to negotiate. Another important aspect that we can talk a little bit about is this concept of optimal viewing position. Now, optimal viewing position is an interesting concept which basically kind of dictates or informs us of the best site to land your eyes on, or say for example from the best place in the word where you can get the maximum information. So the optimal position where if your eyes land, you can get the maximum information out of the word, and consequently can guarantee the maximum speed of reading. So when people read words that are around 5 to 7 characters long, the entire word falls within the fovea, and what people normally would do is they fixate letters just left to the middle of, say for example, for a 5-letter word, just left to the 3rd letter is what you would fixate at, and the entire letter will be within the fovea, and that is the best or the optimal position to read that word. So if you again reach to the next word, you will probably reach just left to the 3rd and the left to the 3rd in all other 5 or 7 letters words, and it kind of ensures that you are reading at a very good fast pace, not really making so many errors. But if words are slightly longer, more than 7 letters or 8 or 9 or 10 letters, most part of the word then will fall into the parafovea, and basically that will reduce your accuracy of reading and also kind of reduce your speed of reading. So in that sense, what happens is that usually people would kind of make 2 fixations on within the same word. So one in the beginning and one at the end, and those 2 fixations will both be spent at the same word to gain information about the word in the most error free manner. That kind of obviously slows down your speed, but obviously you will need to do this in order to get the most accurate information. Now this optimal viewing position, and people have kind of done a lot of experiments and figured this out for a lot of scripts. So this optimal viewing position, basically what it does for the system is that it provides the word processing system with a stimulus that produces the fastest uptake of information. So the whole point of this optimal viewing position is that you know exactly where my eye should land in order to get the fastest uptake of visual information from here. Okay, and in that sense, basically eye movement planning also kind of follows this. So eye movement planning basically should pick up this optimal viewing position in the next word as the target for the current saccade. So while you are reading, while you landed at the optimal position and this word, you are at the same time calculating the optimal position for the next word and the next word and the next word. Okay, so one word at a time you are kind of moving, and while if you are being able to do this calculation correctly and in a fast way, you can eventually be able to read all of this in a very quick way and in also without making too many errors. So if the saccade successfully lands on the optimal viewing position for the next word itself, lexical access procedures have the best possible visual image to work with, and eventually the entire process kind of gets fastened and it gets error free. When say for example the word length option is degraded, it is not really very clear, it is a longer word or something like that, the saccadic planning mechanism may not be able to identify the target word's optimal viewing position, and then that is why the readers will not really have the ideal visual scenario, their reading will slow down, maybe they might commit a few errors in order to read this entire thing successfully. So basically so this is all that is very important, and then there is this thing of there is this last thing that I wanted to talk to you about is foveating. So the whole point of moving your eyes across is basically to try and get the best visual image possible to work with for the lexical access mechanisms. So when people want to identify the details of an object that is located in the peripheral vision, they reorient their gaze, they are not really moving the head, they reorient their gaze so that the center of the object falls within the fovea, and within the fovea, and that is where you will get the best image, highest amount of information from that. And this entire business of moving your eyes systematically through the entire page is basically part of what is called foveating. So that was all from me in today's lecture. We talked a little bit about kind of eye movements and also what reading basically involves. Let us move into the next lecture where I will talk to you about particular models of reading. Thank you.